Hello friends, there are three ways we can solve any static problems. First one is, I'm gonna expand on this one, method of joints. Second one is method of section. And the third one is method of members. To solve this particular question, I will use the method of joints because that's being asked to me. And let's start with this question then. So what is the method of joints? So I'll give you a little bit briefing about the method of joints. It is in this method we draw the free body diagram about a point. So for example, in this case it's been asked determine the load in member AC. So what I'm going to do is, if I wanted to find the load in this member, I can draw the free body diagram about point A, or I can draw the free body diagram about point C. Both will give you the right answer. So right now I'm going to try and draw the free body diagram about point C. Again, when we draw a free body diagram about a point, we always try and show the load acting away from that point. That's the convention we use. So in this CD, I will show the direction of the load away from point C. In this one, I will show again the direction of the load away from point C, and this one also. This is point B, and I'll show it in the away direction. Now this is point C, this is point D. If I wanted to find the load in member AC, I need to know at least either BCB or I need to know CD. Only then I can find the answer to this question. But I don't know the value of CB, neither I know the value of CD. So what I'm going to do is, I'm going to try and see how can I find the value of load in member BC or CB for that matter. Now if I try and draw the free body diagram about point B, so what you're going to do is you will try and draw the free body diagram like this and like this. This is point B, and then this is like this. Now you are tempted to draw this direction towards the upward side, because that's what we said, that we always try to draw the direction of the load away from the point. But if I see in this question, the direction of the load is already given to me, so I won't draw it in the upward direction, so rather I will draw it in the downward direction. Now not only I'll draw it in the downward direction, so if we know the concept of the vectors, if we know them in detail, so we can draw it down here also, because it's the same line of action. Along the line of action you can draw it anywhere, it won't change the answer to your question. So I'll draw it in the downward direction, so this will make my life much easier. So this, even you're drawing it on here, that's still gonna give you the right answer. So it's your call. I like to draw it this way because it makes my life easier. So this is point B, this is point C, and this is point A. And this is 20 kilonewton. So I'm going to write the equation, two equations which we've learned, sigma f of x equal to 0, and the other equation is sigma f of y equal to 0. For method of joints, again repeating, we need only two equations. We don't need the moment about a point when we are solving a question with the method of joints. So let's write down the equation for this one. So I can say sigma f of x, I'm going to use this equation. I can say AB negative times, so what is the slope of AB? If I look into the slope of AB, it is AB is in the horizontal 4/5, and then BC is positive. This is towards the right hand side of point B. Anything towards the right we consider it positive, anything towards the left we consider it as negative, plus BC equal to 0. But I don't know the value of AB, I don't know the value of BC, so I can't solve it. Now what I'm going to do is, I will try to move towards the sigma f of y. So sigma f of y equal to 0. I'll write down this equation. This equation will be it will be 3/4 AB, and this is in the negative side because this is in this component is acting in the downward direction. I'll change the color, and this component is in the downward direction, so that's why this now minus 20, because 20 is also acting in the downward direction, equal to 0. So AB value will come out to be 33.33 negative. When you're gonna solve this is the value you're gonna get. So once we got this value for AB, I'm gonna put this value back in this equation for horizontal equation which we've written earlier. So now this is 33.33 negative, and there was a negative with this, so I'm gonna put a negative here also. This is really important to understand. So if this negative is given to me, I'll use the negative sign while filing the value in the equation also, times 4/5 plus BC equal to 0. And now if I do a bit of calculation, this value should be 33.33 times 4 divided by 5. That's gonna give me 26, positive 26.66 plus BC equal to 0. So BC value will come out to be negative 26.66. Or I can say the direction which we assumed has to be, in this case I assume the direction of BC as in away from the point B, but because this is a negative sign, so I have to change the direction 26.66, and this direction will change to this side. That will be the answer value for BC. But I don't need to find the value of BC, I need to find the value of my final answer. I need the AC. That's what's matter to me. I shouldn't say that I don't need to find, I need to find it, but it doesn't matter what is the value of BC is. Now BC we figured out. So I'm gonna go back to this diagram because we've already figured out the value of BC. So let's see how we can use this value back in here. So I'm gonna write down an equation for this diagram now. So I'm gonna say sigma f of x equal to 0. So in this I can write as BC, which is acting in the negative direction, minus AC, and then I need the slope of this line. The slope is given to me 7.5. So I have to do the calculation for this one. So 7.5 plus 9 and square root 65.25, 8.07. So this value will come out to be 8. This slope comes out to be approximately 8. I'll put it as an 8. It is actually 8.07, so I'll use 07 also so that we can get the more accurate results. So negative BC acting in this direction, and AC, this is 7.5, and this value is 8.07. so AC, this will be 7.5, 8.07. and is there anything else acting in the horizontal direction? No, this is equal to 0. Now when I'll file the value of BC, what was the value of BC we got the BC value is negative 26.6. I'm gonna use this value because I'm not playing with the signs. I'm using the signs as per our commitment that anything from point C, or I'll show the load, the direction of the load away from the point C. So I have to use the negative sign. So I'll put this negative 26.66 here. Is it the negative 20? Yeah, this is the value, minus AC 7.5, 8.07 equal to 0. Negative becomes positive, 26.66 minus AC 7.5 divided by 8.07 equal to 0. Now if I wanted to simplify, AC value will be equal to this is negative 26.66 times 8.07 divided by 7.5. So this value is 26.66 times 8.07 divided by 7.5, 28. Then AC, the load in AC is 28.69 approximately, and this value comes out to be positive. So the direction of AC, whatever direction we assumed, is correct. So that's the value of AC, and that's about it. Let me check the final value in the book. So the answer is, yeah, we got the correct answer. So that is the correct answer. Hopefully you were able to understand the method of join. See you in the next video. Bye now.